right, so let's finish our notes from 4.3. We're going to really concentrate on the unit circle, which is on this side. So briefly yesterday, we discussed that the A, the S, the T, and the C was all students take calculus. And what that's telling you is that all sine is positive, cosine is positive, tangent is positive in quadrant 1. In quadrant, this is quadrant 1. For those of you who don't know, this is quadrant 2. So in quadrant 2, only sine is positive. Everything else is negative. In quadrant 3, only tangent is positive. And in quadrant 4, only cosine is positive. All others are negative. So that's what those are telling you. Then, all you have to do is really know quadrant 1, and then your north, south, east, west coordinate points. And everything else you ought to be able to derive or calculate or count or figure out. So let's just start with our north, south, east, west points. And before I do that, let me just reiterate something else. So instead of finding your notes, each degree on the unit circle is associated with an ordered pair, because I'm going to take my radius, and I'm purely looking at the circumference only. And so as I travel around that circle, there is numerous ordered pairs. You really are going to be crazy. Just do 110. I cannot talk over that. It's like nails on a chalkboard. Hurry up! Keepers. I'm getting a little stressed there. All right. So every ordered pair in this, every ordered pair on this circle, the x is your cosine and the y is your sine. Always, Logan. And it goes alphabetical. X comes before y alphabetically. Cosine comes before sine alphabetically. So whatever the x value of the ordered pair is, that's going to be the cosine of that angle measure, and the y value of the ordered pair is going to be your sine. Also, you're going to have to know tangent. Tangent is equal to y over x, and here's y. So as you're looking in the unit circle, and I create this reference triangle, here's theta. Isn't this your y distance here? So this is your y distance. Isn't this your x distance here? And then this is your hypotenuse here. In our unit circle, our hypotenuse is our radius, and it's vicariously going to be 1. So as I find sine, cosine, and tangent, well, sine is opposite over hypotenuse, so it's y over 1. That's how we get y. Cosine is adjacent over hypotenuse, so it's x over 1. So that's how we get x. And tangent is opposite over adjacent, so that's why it's y over x, which in our case, wouldn't that be sine over cosine? Because y is the sine value, and cosine is the x value. So that's how we can just say that, oh, the x value of the ordered pair is cosine, the y value is sine, using that special right triangle, knowing that we have a radius of 1 in the unit circle. We call the unit circle because we allow the radius to be 1 unit. All right, so let's start off here at 0 degrees, which is 0 radians. What is this ordered pair right here if my radius is 1? I go here, I go right 1 and up 0. So isn't it 1, 0? So that means the cosine at 0 degrees is 1. The sine at 0 degrees is 0. Then I'm going to travel up here to 90 degrees. What's the radiant measure at 90 degrees? Well, if this is 180 degrees here, and 180 degrees is equal to pi, because we've used that a lot, isn't this halfway there? So it's pi over 2. what is this ordered pair for that point right here? If the radius is 1. 0, 1. So the cosine at 90 degrees is 0. The sine, bless you, at 90 degrees is 1.
Wait, why is it 1?
Because the y value is your sine. The x value is your cosine. Based upon what we said here. Right? I'm just increasing the angle. Then over here at 180 degrees equals pi, what is this order pair? We're now going negatively on the x-axis, so it is -1 to 0. So the cosine of 180 degrees will be -1, and the sine will be 0. So we jump up for joy when they give us degree and radian measures that are the north, south, east, west coordinates of our unit circle, because we just think of the order pair. We don't have it. And you really don't have to memorize the order pair, because if you know the radius is 1, you just have to think of, okay, what is that order pair, which is exactly what we're doing here. So what is 180 degrees plus 90? So this is 270 degrees. What's the radian measure? 3 pi over 2. And so what's this order pair? 0 to -1. So the cosine at 270 degrees is 0, and the sine is -1. Finally, we actually have another set here. As we reach here, doesn't this become 360 degrees with a radian measure of what? 2 pi. So 0 degrees and 360 degrees are coterminal angles. They both have the same sine and cosine. Cosine is 1, sine is 0. Alright, so then we have to fill out the rest of this. As I told you, I'm not big on memorization. What I am big on is using special right triangles within the unit circle. So you don't have to memorize this at all. You can create the whole thing using special right triangles, but you have to know what goes where. You always have 3 markings within each coordinate grid. And you know in your special right triangles, the only angle measures are 30, 60, and 45. So 30. What's the smallest measure out of those 3? 30 degrees. So this has to be smaller than that one because we're opening up, that's the first angle, it's the smallest. So if I connect from here to the origin, and then I make a right triangle straight down to the x-axis. This is my 30 degrees. So if that's 30 degrees, isn't this 60 right there? So I know that this is 30 degrees here. We'll do the radian measure in a minute. What's always across from 30 degrees in our special right triangle? 1. Aren't y's 1, or aren't y's positive in this quadrant? So it's a positive 1. What's across from the 60? Rad 3. Isn't x positive in quadrant 1? Everything's positive in quadrant 1. And then what's your hypotenuse? 2. So we're going to find sine and cosine. Cosine comes first in the order pair because that's x. So for 30 degrees, what's the cosine? Cot. Another adjacent hit the hypotenuse. So isn't it radical 3 over 2? That's cosine. What's sine? Opposite over hypotenuse. So 1 over 2. Did I memorize anything other than knowing my special right triangle? Nope. All right, then the next degree measure. What's the next largest degree measure? Well, we've got 30, 60, and 45. 45 is smaller. So then this must be 45 degrees. So I'm going to put 45 degrees here. And so from here to the origin, I'm going to lightly draw in. that, and then I'm going to go straight down and make a reference triangle. So then from here to here, that's 45 degrees. Doesn't that mean that this is 45 degrees also? You know, you're just looking at the green, so I'm using different colors. So now you're looking just at the green triangle. We have a 45, 45, 90 triangle. What's across from the 45s? What number? 1. And so across from this one is also 1. What's the hypotenuse on the 45, 45? Rad 2. So then I'm going to find my sine and cosine. So cosine comes first. Cosine, this is my angle of reference, is adjacent over the hypotenuse. Well, adjacent is 1. Hypotenuse is rad 2. Do I want to write it as 1 over rad 2? We want it rationalized. So what's 1 over rad 2 rationalized? Rad 2 over 2. So this is radical 2 over 2.
Sorry, why did you do cosine?
Because cosine is always first. Because it goes alphabetical, cosine, sine. I know we're used to doing sine first, but alphabetically cosine comes before sine. And then sine, isn't it opposite over hypotenuse? So it's the same thing. 1 over rad 2, which rationalizes exactly the same, rad 2 over 2. Then that leaves us with our 60-degree angle. So this is 60 degrees from here. And I'm going to go straight down. To here. So from here to here is 60 degrees. So if that's 60, isn't there 30 up here? So always across from the 60-degree angle is what? Across from 60 is what? Radical 3, so this is rad 3. Across from 30, always. Across from 30, rating, thank you, is 1. And my hypotenuse is just 2. So when I do my cosine and then my sine, my cosine is adjacent over hypotenuse. So here's my 60. Adjacent is 1. My hypotenuse is 2. So my cosine of a 60-degree angle is 1/2. My sine is opposite over hypotenuse. So that's radical 3 over 2. So we're done with our ordered pairs in quadrant 1. We have to come up with a radian measure. So I kind of hinted at you as we were using our degree measure how to find the radian measure. So what's 180 divided by 30? 6. So isn't this pi over 6? What is 180 divided by 45? 145 is going on. 4. So this is pi over 4. And then what is 180 divided by 60? 3. So that's pi over 3. So that's how I remember those. Then, all we have to do, well, first of all, there's a couple ways that you could view quadrant 1. So you could do exactly what we just did, use your right triangles and derive it. Now, it took me a little while to explain it, but typically you can get that done in usually a minute, 2 tops, if you know your right triangles. You don't have to do them inside the circle, you can do them off to the side and figure out what they are. Do you see a pattern forming here? And I'm going to move this up here. What do you notice that is the same about every ordered pair? Look just at the ordered pairs. There's 2's where? All the denominators, except for the north, south, east, west points, but all the denominators here are 2's. So you know that in every ordered pair, with the exception of north, south, east, west, your denominators are always 2. Okay, so let's look at the numerators. What do you notice? Look at the x's. You start with 0, 1, 2, 3, back to 1. So the opposite of 0, 1. Then look at your y's. If you start over here at 0, how do your y's go? 1, 2, 3, back to 1. Isn't there a pattern to that? And in your numerator, your 2's and 3's always are under what? A radical. So you could memorize it that way. If you know that your north-south is 0, 1, then up here you just go, okay, 0, 1, 2, 3. That one's 1. Well, that one's 0, 1, 2, 3. Put your radicals in, put your denominators in, you're done. Then you have to figure out your degrees. Well, to figure out your degrees, you know that this one, because you always know there's 3 in between here, this one has to be the smaller of the 3 that we know, 30, 45, 60. Figure out your radians. That's actually quicker than doing your triangles. But for some of you, that pattern won't stick in your head. For others of you, you're like, oh, I got it, that's perfect, I'm done, I'm not doing right triangles. And I will tell you that right triangles are helpful to know so you don't have to like create your unit circle all the time. So then, how do you find the rest of it? Because you're going to be given a test just like this in about 2 weeks. It looks like this, but it's blank. You have 5 minutes to fill it out. There should be no reason why you can't do it in 5 minutes if you understand all of what we're doing. So then to find the rest, all we have to do is slide. Notice in quadrant 1, x and y's are always positive. So all the ordered pairs are positive. And all we're doing is sliding those ordered pairs over here. Notice I didn't say reflect, we're sliding. We're sliding our ordered pairs down here, and then we're sliding our ordered pairs over here. So and we go from quadrant 1 to 2 to 3 to 4. It goes in that order. So all we're going to do is slide. Bless you. So I'm going to take this and slide it directly across here, and I get 1 over 2, and radical 3 over 2. And then I'm sliding the middle over here to the middle, rad 2 over 2, rad 2 over 2. And I'm sliding this over here, rad 3 over 2, 1/2. But we have to figure out signs. In quadrant 2, are x's or y's negative? Or both? What's negative in quadrant 2? X's. So only my x part of the ordered pairs are negative. And make sure that the negative is clearly separate from the division bar. Are you with me? Did you put your negatives in? So then we're going to slide these down here. You want to slide to where they are the same distance from the x-axis because we're sliding over the x-axis. So these ones come first. They're the same distance away. So I get radical 3 over 2 and then 1/2. Then these ones are the same distance away. Notice that the middle ones are always rad 2 over 2 of some sort. The signs just change. So I'm just sliding these down. Then these are the furthest away, so they're the same. So I'm just sliding the 1/2 down and the rad 3 over 2 down. So all I did was slide quadrant 2 to quadrant 3. Now, what's negative in quadrant 3? X's or y's or both? Both. So both parts of the ordered pair gets negative. I have no idea what angles those are. Doesn't matter. I'm sliding. Then for quadrant 4, you're going to slide this over here. So these two are the furthest away. So these two belong together. So radical 3 over 2 and 1/2. Then comes these two. Rad 2 over 2. Rad 2 over 2. And then these two. 1/2. Rad 3 over 2. What is negative in quadrant 4? Just the y's, right? Yeah. So negative, negative, negative. So there's our order pairs without doing right triangles. Done. Let's figure out our angle measures. So let's start with our degrees. So let's do our 45s first. Get those out of the way. They're the ones in the middle. So if this is 0 to 45, 45 plus 45 is 90. What's 90 plus 45? 135. And then 135 plus 45 is indeed 180. So then we're going to take 180 and add 45. What do we get? 225. And 225 plus 45 is indeed 270. Then what's 270 plus 45? 315 degrees. And 315 plus 45 is 360. So I just keep adding that to make sure that I didn't make a mistake when I added something previously. Then we're going to count by 30s. Because when I count by 30s, when I get the 60s also, and we'll fill in everything else that's left over. So I've got 0 to 30, 30 plus 30 is 60, 60 plus 30 is 90, 90 plus 30 is what? 120. 120 plus 30, we're skipping over the 45, is what? 150. 150 plus 30 is 180. What's 180 plus 30? 210. 210 plus 30? 240. 240 plus 30 is 270. 270 plus 30? 300. 300 plus 30? 330. And 330 plus 30 is 360. Radian measure. Again, you might want to start with a pi over 4. We're going to count by 4s. So when we count the fourths, we only count in the middle and all the north, south, east, west. So let's start here. So this is 0. 1 pi over 4. Isn't this 2 pi over 4? Which is 1/2. So what's this one? 3 pi over 4. And then north, south, east, west. So if this is 3 pi over 4, isn't this 4 pi over 4? Which makes it 1. Then what's this one? 5 pi over 4. So if this is 5 pi over 4, add 1 more, isn't this 6 pi over 4? So 6 pi over 4 does reduce to 3/2. So if this is 6 pi over 4, what's this one? 7 pi over 4. I just keep talking to myself. And if this is 7 pi over 4, add 1 more, this is 8 pi over 4. Doesn't that reduce to 2 pi? So we're done with the pi's over 4. But last, we're going to count by 30s, or by pi's over 6. If I count by pi's over 6, my pi's over 3 are going to reduce also. So this is 1/6, 2/6, which reduces to 1/3, 3/6, which is 1/2. This is 4/6, which reduces to what? 2 pi over 3. This is 4/6, so this is what? 4/6, this is 5/6. So 5 pi over 6. If this is 5/6, then this one is 6/6, which is pi. This is 6/6, so this one is 7/6. Sorry, I made this last one. 7 pi over 6. So if this is 7, this one is 8 pi over 6, which reduces to 4 pi over 3. So this was 8. So this one is 9 pi over 6, which reduces to 2 pi over 2. So this was 9. So what's this one? 10 pi over 6. So what is that? 5 pi over 3. So this was 10. So this is 11 pi over 6. And that means that this is 12 pi over 6, which is 2 pi. So we're done. That's all you had to do. So, knowing that, let's answer some questions on the back. Is there any questions on the unit circle before we move on? Does that feel okay? Okay. So then, here you've got a couple of choices when you're answering these questions. These are similar questions to what we were answering yesterday. So if I'm from the sine of negative 150 degrees, you can do it one of two ways. I can, and this is typically how I'm going to do it. I'm going to create my coordinate grid, and I'm going to figure out where it's on negative 150 degrees. Doesn't that mean I go clockwise? Go backwards? So if this is 0 degrees, this would be negative 90, this would be negative 180. So it isn't negative 150 degrees in quadrant 3 here somewhere? So from here to here is my negative 150 degrees. So yesterday I did teach you, extend out that, to draw a reference triangle straight up or down, in this case up, to the x-axis. And so this is my reference angle right there. What's my reference angle going to be? If this is 150 degrees and all the way here is 180, what's my reference angle? So this is 30 degrees. So this is a 30, 60, 90 triangle, right? So I can still rely on what I did yesterday. What's across from 30? 1. In this case, isn't it negative 1? What's across from 60? Rad 3. And in this case, isn't it negative radical 3? And what's my hypotenuse? 2. So to find the sine, don't I just do opposite over hypotenuse? Negative 1/2. So I can still do what we did yesterday. And I tend to rely on that because I don't memorize the unit circle. Now, if you know your unit circle, look what we can do. Negative 150 degrees means I still know I have a 30-degree angle here, right? So as I go in the unit circle backwards, there's my 30-degree angle right here, because between these two, that's a pi over 6. Anything over 6 is a 30-degree angle, because 180 divided by 6 is 30 degrees. So I know that I belong here. Look at the ordered pair associated with 7 pi over 6, or the 210-degree angle. That is coterminal to my negative 150-degree angle. We're finding sine. Is sine x or y? Y. What's the value of y on this ordered pair? Negative 1/2. Didn't we get the same thing? So your unit circle, you can actually get it quicker if you know your unit circle. Choose not to memorize your unit circle. Can't we still do it this way? So off of your unit circle, the ordered pair that we had was negative radical 3 over 2, common negative 1/2. That was the ordered pair. This was the value that was sine, because this one's cosine. So either way, this is way 1, this is way 2. Yes. It doesn't matter which way. Yes.
So is the test literally going to be like a blank with circle to you and just go?
Not the test on Thursday, but in 2 weeks I'll literally give you a blank thing like this, and I'm like, you got 5 minutes, fill it out. And so if you can do what I just did, you can do that in 5 minutes without a calculator. You don't have to make the triangles. No. You can make them off to the side up here too if you want to. If you don't want to gunk this up in here, I was just showing you where they're coming from and how they apply to those. And typically I'll do them off to the side. I was doing it in there for demonstration purposes. All right, so tangents. We can find all 6 trig functions no matter what we do. Tangent of 4 pi over 3. So I'm going to draw my coordinate grid. And you can find what 4 pi over 3 is. So again, you can use your unit circle to count, and also count here, because you'll get used to counting. If this is 0 radians and this is pi radians, then is this more than pi or less than pi? More than pi. So this is 1/3, 2/3. Wouldn't this be 3/3? Would 4/3 pi be right over here? So I know I'm going to draw my angle from here to here. And so my angle measure that I'm finding, this is your 4 pi over 3. That's your angle. But you're going to draw a reference triangle directed to the x-axis right here. This is a denominator of 3. So what's 180 divided by 3? 60. So isn't my reference angle here 60 degrees? And I got that by just looking at the denominator. Has to be 60 degrees. So if that's 60, isn't this 30? What's across from 30. It is negative 1, very good. What's across from 60? Negative radical 3, and what's my hypotenuse? 2. So if I'm finding tangent, so my tangent of 4 pi over 3 is equal to opposite, this is my angle of reference, so opposite negative 3, radical 3, sorry, over adjacent negative 1. The negatives cancel out, we don't write it over 1, and so don't you get a positive radical 3. Now, how do you do this using the unit circle? Well, this is way 1. I personally like that way. But if we use the unit circle, so we'll do way 2 here. Look at the ordered pair at 4 pi over 3. So let's find 4 pi over 3. Isn't it right here? Our ordered pair is negative 1/2 negative rad 3 over 2. The ordered pair at 4 pi over 3, the ordered pair is negative 1/2 radical 3 over 2. Logan, a lot of you are just zoning out here today. I just see this. So remember, this is my cosine and this is my sine. What did we say tangent was? What over what? Sine over cosine. So tangent of 4 pi over 3 is equal to sine, let's see if I can put this in here so you can see it, which is radical 3 over 2 divided by cosine, which is, and that's a negative, this is negative, and cosine, which is negative 1/2. So we have a fraction divided by a fraction. What do we do? Yeah, you take your numerator, which is negative radical 3 over 2, and you multiply it instead of dividing by the reciprocal of the denominator, negative 2 over 1. Don't the 2's and the negatives cancel? Aren't you left with rad 3 over 1, which is radical 3? Did I get the same answer either way? Yep. So way 1, way 2. What's wrong? That's why I fully rely on my special right triangles constantly. But there are some people that really like the unit circle. And we're going to use the unit circle often in certain places. And so you do need to know the unit circle, and I'll use the unit circle certain times. But I personally rely mostly on reference triangles. I do find them easier. All right, so let's look at the cosine of 180 degrees. Anytime you see a degree or a radian measure, that is your north, south, east, west reference points. You know what I mean when I'm saying north, south, east, west reference points? Okay. How do you know in radian measure whether it's a north, south, east, west reference point? Well, if it's a whole pi, you know, like 96 pi. I don't know if that's true yet, but it would have to be. So if it's any whole pi, that's either an east or a west. Or if it's over 2, isn't that a north or a south dimension? Okay, so that's one way. But with these, you just have to divide it out by 180 or 360 to see how many of those you might get. So my point being, cosine of 180, what is the ordered pair at the cosine of 180 degrees? Negative 1, 0. That's our ordered pair. Isn't the negative 1 my cosine and isn't the 0 my sine? There's really no work to show for this. So therefore, the cosine of 180 degrees is exactly equal to negative 1. It's that ordered pair. Done. Now, if I asked you for the sine of 180 degrees, you would have said 0. What would be the tangent of 180 degrees? Correct, because tangent is what over what? So it'd be sine over cosine, so it'd be 0 over negative 1. Isn't that defined as 0? You would not give me the answer 0 over negative 1. You would say 0. What about cotangent? It would be undefined because cotangent would end up being negative 1 over 0. You can never have 0 in the denominator, so your answer has to be undefined. Is secant or cosecant undefined? What's the reciprocal of negative 1? So this is negative 1 over 1, isn't it? When you flip it, take the reciprocal, isn't it still negative 1? What is the inverse function to cosine? Secant. So secant is also negative 1. This is technically 0 over 1. What's the reciprocal of that? 1 over 0. Is that defined? No. So what is the inverse function of sine? What is it called? Cosecant. So cosecant is also undefined. So cosecant and cotangent are both undefined. So you're not always going to get, so at your north, south, east, west axis points, you're going to get undefined values. And when we look at the graphs of these trig functions later, which we will get into, you'll start to see where they're undefined and why. All right, so then last one on this section. Let me get outside of it for a minute. Secant of 11 pi over 2. So I could convert that to degree measures, but I still, yes. I can't hear over the lower. Yeah, you're just, no, you're not. We're just looking at the other forms just so you can see, because they could ask you anything. It just so happened I asked for cosine. All right, so secant of 11 pi over 2. I have to know exactly where that is. Is that at 90 degrees or is that at 270 degrees? So I would immediately draw my unit circle. I would just draw a little sketch of my unit circle like that. And I can count half pies. I need 11 half pies. So wouldn't this be 1, 2, 3, 4, because each of those are half pies, aren't they? Agreed? Huh? No. From here to here is a pie. From 0 to here, that's a pie. So therefore, from here to here is a half of a pie. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 halves. So doesn't 11 pi over 2 end up there? I was having a little trouble with it. So what's the order pair here? The order pair here is 0, negative 1. So secant, I don't like secant. What are we going to convert secant to? So we want to find 1 over the cosine of 11 pi over 2. That's what secant is, 1 over the cosine. So isn't this the cosine here? So that means that secant of 11 pi over 2 is the same as 1 over the cosine, which is 0. Is that defined? No. So secant of 11 pi over 2 is undefined. You okay with that? Okay. Then the last type of problems that you're going to have are problems where you're asked to find on this particular one just cosine and tangent. So thank goodness not all 6, right? Just cosine and tangent. Don't find more than you have to. And they give you some helpful hints. Before, when we were told that the sine of theta was 3/7, we really weren't looking at it in the coordinate grid. If I look at the sine of 3/7, you remember this? All students take calculus. True or false? All right, so they're telling you here that the sine of theta is 3/7. 3/7 isn't that an overall positive number? I don't know what theta is, but it's an overall positive value. Where is sine positive? It's positive here and here, isn't it? All means all of them are positive. Here means just the sign is positive, the rest are negative. So in quadrants 1 and quadrants 2 are where sign is positive. So if that's how they ask the question, I'd have to give 2 answers for theta. Because we're trying to find, well, we're actually trying to find the ratios, not theta. But I'd give 2 ratios. There's 2 places where that answer would be. However, they tack on something else, don't they? They say that tangent is less than 0. What are they trying to tell you? Yeah, so here they were telling us that sine was positive. Here they're telling us that tangent is negative. The easiest way to find out where tangent is negative is find out where tangent is positive. Where's tangent positive? 1 and 3. So if tangent is positive in 1 and 3, isn't tangent negative in 2 and 4? Where do they, so this is quadrant 2 and quadrant 4. Where do they overlap? Right here is where they overlap. They both have a quadrant 2, don't they? So that means that we're going to draw a reference triangle in quadrant 2. So they've narrowed down our 2 choices to quadrant 2 only. So I'm immediately drawing my reference triangle in quadrant 2. And here's my theta. Because they gave me sine, I know that sine, sum, old hippie, would be opposite 3, hypotenuse 7. I don't know x. Is that a Pythagorean triple? No. So step 1 is what we just did. Figure out what quadrant your answer is going to be in, because that helps us with sines. And so then step 2, we've got to find x. So x squared plus 3 squared equals 7 squared. So we're back to the problems that we worked with several days ago. X squared plus 9 is equal to 49. Subtract 9. X squared is equal to 40. Take the square root of both sides. Are there any perfect squares in 40? 40 is 8 times 5, which is 2 times 2 times 2 times 5. Can't we get a pair of 2's out of there? And then we're going to leave that underneath. So x is really equal to 2 radical 10. So when I take out a pair of 2's, but only one of the 2's comes out in front. So that means that x is 2 rad 10. You've got to simplify those radicals. So then step 3 is to find the values that they're asking for. Cosine of theta is cosine cot, another hippie. So adjacent over hypotenuse, 2 rad 10 over 7. And that doesn't use. Then tangent of theta is opposite over adjacent. So 3 over 2 rad 10. I'm perfectly happy with that as an answer, and I believe Math Excel will be as well. Ellie, you writing? You missed a whole step. You didn't miss this step here? Did you do it ahead of time? Yes. Rationalize it, you mean? You could. I choose not to. I mean, if they're going to waffle back and forth, then we're going to stay with the waffling. And we're going to stay there. All right. The only ones you have to rationalize are where? The special right triangle, degrees, 30, 60, 45. Those are the ones that I want written rationalized. The rest of them, you don't have to. All right, so then look at this one. How is this one different and or more difficult than the previous one?
Opposite.
Secant. They gave you secant. So we don't like secant. So instead of secant, we're going to convert that to what? Well, we could do 1 over, but instead, secant's inverse function is cosine. Take the reciprocal of this. Don't do 1 over cosine because we want the ratios reciprocal. So cosine is going to be 1 over 3. That's what we're going to use. And then we find one of the answers that we're looking for. Right? So cosine is positive, isn't it? So in my coordinate grid, all students take calculus. Where is cosine positive? 1 and 4. Then they give us sine, and sine is what? What is greater than 0? Positive. So sine is positive in quadrants 1 and quadrants 2. Where do they overlap? Quadrant 1. They both have quadrant 1. So this is step 1, figuring out all that. Step 2. Let's figure out, we're in quadrant 1, so put a reference triangle in quadrant 1. Here's theta. So they gave me really cosine. So cosine is cot another hippie. So adjacent is 1, hippie is 3. It's not a Pythagorean triple, so we have to find x. So 1 squared plus x squared equals 3 squared. 1 plus x squared equals 9. Subtract 1, x squared is 8. So when you take the square root of both sides, what's the square root of 8? Yeah, 8 is 2 to 2. So you can pull out a pair of 2's. So x is 2 by 2. So for step 3, we already found cosine. So cosine of theta, again, is 1/3. So tangent of theta, right, but they want us to find cosine and tangent. We already found cosine earlier, right? And so we want to find tangent. So tangent is opposite to rad 2 over adjacent, which is 1, which is written 2 rad 2. Question?
How do you put the sign
Why don't I?
in? Yeah.
They didn't ask for it. They gave us sine as a restriction because secant and or its inverse cosine is positive in 2 different quadrants. So in order to narrow it down so we don't have 2 different answers or 2 different places that we're looking for the answer, they narrowed it down to also where sine is positive. So we only used sine to narrow down our quadrants and cut out one of the quadrants. They only asked for cosine and tangent. They didn't ask for all 6 straight functions.
Yeah, that's what I thought too.
Right? So just because you see sine there, or they could have put cotangent there, they could put anything in there. Just because you see that doesn't mean that you have to find it.
Okay.
Does that make sense?
Yeah.
Okay.